Hi guys, and welcome to another video, and we're going to be looking at elastic potential energy. Now if you remember from our first video, this is just the energy stored in a stretched or compressed object. And you'll need to know how to calculate elastic potential energy for your exams. Now if we use the equation where elastic potential energy is equal to 0.5 times the spring's constant multiplied by the extension of our stretched object squared. We'll have to give some units to this equation for each of the quantities. For example, energy will be measured in joules. The spring's constant is measured in newtons per meter. An extension has to be measured in meters. Now we can represent this equation using the abbreviations, and we can abbreviate it as such where energy is equal to half of the spring's constant times the extension squared. And that means that we can put this equation into a triangle, which makes it easier when coming to rearrange this equation later on. So energy would go at the top, half of our spring's constant would go in the bottom corner, and in the other corner we would put our extension squared. You can see here guys that we've been given a question where we're asked to calculate the elastic potential energy. When given a question like this, I would read through the question to make sure that all of the measurements are in their standard units. For example, here we can see that extension is given in centimeters, and we need that to be in meters. So to convert from centimeters to meters, we just divide by 100. So that becomes 50 over 100, and that gives us 0.5 meters. And now we're ready to use the equation to calculate elastic potential energy. So I would write my equation out. Half of the spring's constant times extension squared. That becomes 0.5 times 3 times 0.5 squared. And if I type into my calculator 0.5 times 3, well that's just 1.5. And then 0.5 times itself, because that's what squared means, becomes 0.25. So the elastic potential energy stored in this spring becomes 1.5 times 0.25. That would give us an answer of 0.375 joules. Now exams tend to ask you to give your answer to 2 decimal places. So to give this answer to 2 decimal places, it becomes 0.38 joules. Let's look at a more challenging question where this time we're asked to calculate the spring's constant. Now again, we have to draw the triangle out where energy goes at the top, half of the spring's constant in the corner, and extension squared. So this tells me that half of the spring's constant is equal to the elastic potential energy divided by the extension squared. So elastic potential energy is 0.6 joules divided by 0.15 meters. Remember, we have to square that number. So in my calculator, I'd want to do 0.15 squared first, which becomes 0.6 divided by 0.0225. Now, if I type this into my calculator, I get a number of 26.6. Now remember that this number is equivalent to half of k, but we want a value for just k on its own. So what we have to do is times this number by 2, which will give us 53.2 newtons per meter. Okay guys, thanks for tuning in. Stay in touch for another video.